All right, welcome back. We're doing Chapter 5, Section 6, talking about slope-intercept form of a linear function. We see linear functions in the world in lots of different places. Most of the time, it's where you have a change using the word per. And we've talked about the word per before. In one of the previous lessons, we talked about this as a rate of change and how we see per in lots of different places. We see it in like miles per hour, cost per ounce, cost per square yard if you're buying carpet or something like that. In other words, when you get to when you have so much of one thing compared to so much of another thing, and that goes back to what we've been talking about with all of algebra. We're comparing two different measurements. If we know what the ratio is between them, we can figure out what the unit rate is. And the unit rate is very, very similar to slope, the rate of change. Sorry, I got the hiccups. Okay, so now we're going to be dealing with this one example, which is kind of a simple example. The problems in the real world are usually more complicated than this, but at least this is where we're going to start understanding real world problems, okay? So if you wanted to rent a moving van, this company charges a $30 flat fee. So you're just going to pay $30 no matter what. And they're going to charge you 50 cents per mile. Now, not every company does that, okay? Some of them do, some of them don't. Sometimes in class we'll be like, well, what if a company did? No, don't try to make a different problem, okay? Just roll with this one, all right? If sometimes, like, if you go to Home Depot or Menards, or I think Lowe's does too. I'm not trying to like plug one big hardware store, but you can rent tools. You can also rent like a truck. If you've ever been to Home Depot or Menards, you see they've got like trucks for rent. All right. Sometimes a company may charge per the mile. So when you get back, they'll calculate how many miles you drove, and then that'll be part of your bill. All right. Other companies don't do it that way. So this is not about those other companies, is what I'm trying to say. All right. This is a graph that shows what's happening. So this would be the number of miles, and this would be the total cost. And by doing this, this tells me that my x, which is my independent variable, is going to be the number of miles that you drive. So in other words, the customer, the person who's renting the van, gets to decide how many miles he, she, or they is going to drive, right? Now I know you're probably thinking, yeah, but like if I have to move, I don't get to choose how far away these places are. Yeah, you're right, okay? But you do get to choose how much you use the truck, all right? So think of it that way. The cost, which is the dependent variable, the cost depends on how many miles that the customer drove the moving van. All right, so I've got my variables labeled here. Let's see if we can write the equation. So my total cost is going to be y. You're going to have a flat fee of $30. I'm going to put the decimal in there, even though we don't need it, just to show that it is money. All right. Now, each mile, you're going to increase by 50 cents. So after 1 mile, you're going to be up to $30.50. After 2 miles, you're going to be at 31. Then 31.50, 32, 32.50, 33, 33.50. You get the idea. How do I write that as an equation? Well, instead of repeatedly adding 50 cents, I'm going to multiply my 50 cents, 0.550. I'm going to multiply that by the number of miles that I drive. Now, there's a couple things. I could have also used D for distance and C for cost, or T for total cost. The problem with that, that's good. That's what we'd want to do, all right? The only problem with it is that if I was going to do something with Desmos or my graphing calculator, then it's not going to know what these are, all right? So that's why we always switch back to X and Y, because it's kind of universal. Desmos knows what x is, it knows what y is, it knows it's the independent and dependent variable. All right, so another way I could have written this would have been c equals $30 plus 0.50 times d for distance. I guess you could also said m for miles, but I'm trying to make sure that you understand that distance is the variable, the number of miles is the distance. Miles is just the unit that you're using. Another thing about this is that it's actually not in slope-intercept form. I'd have to write it this way, 0.50 times x plus 30. So I just switch it around to put the part with the x first, right? Okay, cool. Now I'm going to identify the slope and the y-intercept. That's why I switched it, because it makes it a little bit easier to identify the slope and the y-intercept. The slope is what's being multiplied by the x. So my slope is 0.50. What that means is that I'm going to be charged 50 cents per mile. That's this part right here. That's the slope, which is the unit rate. Go look for the word per. Look with a K for this. Look for the word per. That's going to tell you the slope. My y-intercept is 30. This is where you start when x equals 0. In other words, when the distance is 0, you have not driven the truck. You haven't moved it anywhere. You're already going to get charged a flat fee of $30. Okay? So now this is my graph that shows that. And the last question, I'll move it up so you can see it. Find the cost of the van for 150 miles. So the total cost is going to be, and I don't care which one you use, this one is slope-intercept form, the other one's perfectly okay, but I'll go back to slope-intercept form. 0.50 times 150 plus 30. I know I'm at the bottom of my paper, so I don't have a lot of room. I don't care, you can use a calculator, but the truth is you can do that also in your head. 50 cents is a half of a dollar. Half of 150 is 75. 75 plus 30 is 105. So the total cost is going to be $105. And if you don't believe me, we can do this. 0.5 times 150 plus 30. And I get 105. Oh, maybe you saw that. I'm trying to get the whole thing in the screen. Okay. So the main idea I want you to get out of this is that every part of this equation means something. The x tells me what you get to choose. You get to choose how far you drive this van. The y, you don't get to choose that. They're going to come back and they're going to tell you, you drove the van this many miles, it's going to cost you this much. And you're going to be like, okay. And you're going to hand them your credit card and you're going to be good. And the slope and the y-intercept in this problem don't change. Now, of course, you could go to a different company and maybe they charge a different price here, maybe they charge a different price here. That does not make them variables. For this company, these two things stay constant until, of course, they raise their prices. But these are not variables. The slope and the y-intercept are not variables, but all four parts mean something for the problem. All right, we'll see you in the next video.